and welcome to Design Considerations, discussions by engineers for engineers or anyone interested in learning more about design process. My name is Ed Bray, and I will be your host for today's discussion in our Capacitor series titled Capacitor Basics. I am a technical sales and applications engineer with AEM Group located in Raleigh, North Carolina. Today, I will be talking with Mark Gebbia. Mark has been focused on capacitor technologies for over 38 years. He has held positions in quality and engineering with companies such as Plastic Capacitors, Illinois Capacitor, and Cornell Dubilier. For the past 4 years, Mark has served as the Applications Engineering Manager with Nichicon Americas. Mark's alma mater is Midwest College of Engineering, where he holds a bachelor's degree in electrical engineering. Hi, Mark. Thank you for taking time today to help us understand more about capacitor basics and what we need to keep in mind when approaching capacitors in our designs.
Thank you, Ed. It's a pleasure to discuss capacitors with you.
Every electronic circuit requires a capacitor. So what should we be thinking about when deciding what capacitor to use in our designs?
There are multiple factors in determining which type of capacitor to use. Selecting the correct capacitor is much easier if you know the specifications that need to be met. So let's start with the basic requirements a capacitor has to meet. In many applications, there are a few items we consider a requirement when selecting a capacitor or type of capacitor. Those requirements are capacitance value, applied voltage, operating temperature range, applied ripple or AC current, including the frequency and the physical size. Once we know these, we can determine which type of capacitor is needed and if a single capacitor will meet the requirements or if multiple parts are needed. Now, there may be instances where a capacitor doesn't meet the application requirements or a solution is not viable.
Types of capacitors? How many types are there?
Capacitors are made out of several different materials. We call them dielectrics, and these materials give the capacitor types their names. Each material or dielectric has characteristics to meet a variety of requirements. Today's most common dielectric materials are ceramic, aluminum, tantalum, carbon, polyester, and polypropylene. To make things more interesting and complex, several types of capacitors have subtypes or families such as polymers, hybrids, metallized film, film foil, and impregnated constructions, to name a few. Now, I know this is starting to sound confusing, but it's really not. That's because not every subtype is available to every dielectric. Many are related to the specific dielectric materials. For instance, metallized film, film foil, and impregnated constructions are available only in film capacitors. Polymers and hybrids are subtypes for aluminum and tantalum capacitors. Each of the construction or subtypes gives capacitors more variety and expanded characteristics. So let's go over the different construction styles. Film foil means the film and the conductive metal foils are separate layers. These parts have the highest ripple currents but can fail as a short. Film foil is an older technology limited to inexpensive bypass caps and power film capacitor applications. Metallized film is the most common type of construction available today. The metallized film is where the conductive layer or foil is deposited onto the surface of the film. Metallization gives the capacitor the ability to self-heal or repair itself. It can reduce the size, but other characteristics may not be as good as film foil capacitor. The failure mode is normally an open circuit. Impregnated film is very simple. It means that an impregnant is added to the capacitor for improved voltage withstanding, improved characteristics, and thermal dissipation. Nichicon does not make this type of capacitor.
Mark, I think you skipped a couple, polymers and hybrids. What's up with those dielectrics?
Good catch, Ed. Hybrid capacitors have a solid and liquid electrolyte, but polymers are not a dielectric. They have a solid material replacement for liquid electrolytes. The ripple current and ESR values are significantly improved by replacing the liquid electrolyte with a polymer material. but this does cause the capacitor to lose its self-healing properties. This property is reestablished with hybrid capacitors. The addition of a liquid electrolyte reestablishes the self-healing property while maintaining most of the improvements gained with polymers. Once you've determined the capacitance and construction needed, you still need to decide what lead style you want.
Lead styles?
In most applications, this is an easy one. Capacitors are made with axial, radial, or SMD lead configurations. Axial and SMD parts don't have many additional options, making those selections easy. Radial leads can have many different configurations. Nichicon no longer makes axial leaded electrolytics. SMD or surface mount device is available in two variations, standard and high vibration. Radials are available in a variety of configurations. For electrolytic types, you can choose standard radial lead, snap-in lead, or screw terminal. The standard lead configuration is available in loose or taped versions. Knowing the electrical requirements and the size requirements determine the lead style that is needed. Let me clarify the different radial lead styles. Standard radial leads are round lead wires that can be straight or formed to meet specific PCB mounting requirements. We tend to call these long leaded parts. These parts are easily wave, selective, or hand soldered. Snap-in parts snap onto the circuit boards, as the name suggests. Generally, snap-in parts are placed on the board manually or robotically. Like leaded parts, snap-ins can be soldered the same way long lead parts are soldered. Screw terminal parts are typically attached directly to bus bars or connected by cables with bolts. These are also the physically largest electrolytic capacitors. At Nichicon, the selection of film capacitors is very simple. We sell axial or radial-leaded. The Echo by Nichicon brand of capacitors is slightly more complex. Like Nichicon films, Echo by Nichicon offers axial and radial-leaded parts with either straight or lug leads. The difference with Echo by Nichicon is mainly in the radial parts. They can be supplied with multiple leads or lugs. Axials are either leaded or have a single lug style.
This sounds like selecting a capacitor is a very complex process.
Yes, it sounds complex, but it isn't. Knowing the basic requirements of capacitance, voltage, operating temperature, applied ripple, size, etc. will narrow down the types of capacitors to be considered. For example, if the capacitance is 1,000 microfarads, you've eliminated ceramic and most films. You're left with tantalum or aluminum electrolytics. Now all you have to determine is the lead style. If you know the size or soldering method to be used, helps narrow down things even further. If reflow soldering is going to be used, then you need to select an SMD part. Note, radial-leaded parts cannot be reflowed. If wave soldering or selective soldering is used, they can use radial or snap-in lead styles. Now you might not have all the basic requirements needed to select the correct capacitor. If that is the case, call your Nichicon sales rep and they will be able to help select the correct capacitor.
What happens when there isn't a part that meets the requirements given?
That's a great question because it does happen. Now it's time to ask additional questions, and compromise may need to be made in the design. A different size part may be needed, or a bank of parts may be needed. Design may have to give up some electrical design buffers too. Or the compromise might require more space than originally planned. The compromise will often have a small or limited impact on the project, and you can proceed easily. If no compromise is possible, design might have to be redeveloped or completely changed. The best way to avoid those kinds of issues is to get us involved early in the design process. We can help avoid some of these problems.
Are there any rules of thumb or general guidelines?
Actually, there are some guidelines. If the voltage applied is AC, use film capacitors. Capacitances over 1 microfarad, use aluminum electrolytic and possibly tantalum. We prefer aluminums. Capacitance is below 1 microfarad. Your choices are films or ceramics. We prefer the films. DC voltages above 600 volts, use film capacitors. X or Y caps are definitely film capacitors.
Well, Mark, you have given us a lot to consider. Thank you again for taking time today to help us understand more about capacitors and the things we need to keep in mind when deciding what capacitors to use in our designs. And thank you for listening. If you would like to be added to our mailing list, would like a copy of the transcript, or have topics you would like to hear discussed, go to our website at aemgrp.com and submit under the Contact tab. Next time in our HMI series, we will be discussing HMI basics. Until that time, may your designs be safe, robust, and efficient. Goodbye for now.